Ms. Lindquist. So we're going to finish off part 2 of Law of Sines by talking about area of a triangle. So given two sides and an included angle, so a side angle side. So for instance, if you had little a and little b and its included angle C, then the area of the triangle would be 1/2 times a times b times the sine of angle C, the included angle. Or we could write it two other ways. So as long as you have two sides and their included angle, you can use this formula to find the area of a triangle that is not a right triangle or an oblique triangle as you see above. Example 2 says find the area of the given triangle, round to the nearest tenth. And we can see here we're given side, angle, side. So since we know two sides and their included angle, we can use the formula that we just discussed. So the area of this oblique triangle will be 1/2 times 2 times 3 times the sine of their included angle, which is 35 degrees. Again, when you put this in the calculator, make sure that you are in degree mode since you're taking sine of a degree measure. Well, we can simplify this up. This is going to be what 2 times 3 is 6 times 1/2, which is going to be 3 times the sine of 35 degrees, which is going to make our area approximately 1.7. And the units on this is going to be centimeters squared since we are talking about an area. And if you think about it, this was 2 centimeters and this was 3 centimeters. So technically that, when we multiplied that together, it would have been 6 centimeters squared. Okay, so why don't you guys take a moment and try to figure out example B. So you're going to want to start off with labeling your angles, A, B, and C, and the information that they're giving you. So go ahead and pause the video and try this out. So when I filled this in, the side across from angle B is 5 inches given here, and little c is 10 inches, so this would be this side length, and they give you the measure of angle A is 31 degrees. So we do have a side angle side. So we can go ahead and use our formula. So we're going to have 1/2 times 10 times 5 times the sine of the included angle of 31 degrees. So again, we have 50 times 1/2, so we're going to have 25 times the sine of 31 degrees, and we can put that in our calculator. So our area is going to be approximately 12.9, and since we have inches as our side lengths, our area will be in inches squared. Example 3. A surveyor locates points A and B at the same elevation of 3,950 feet apart. So they're at the same height on the mountain. So here's one of his locations, and here is the second location, and they are 3,950 feet apart. At A, the angle of elevation to the summit of the mountain is 18 degrees. Remember, we talked about angle of elevation is up from horizontal, so that is that 18 degrees that when he's at this location, he'll have to look up to see the top of the summit. And at angle B, it says that the angle of elevation is 31 degrees. So here he is going to have to look up 31 degrees, which makes sense because he's a little bit closer to the mountain here. So he's going to have to look up a little further to see the top of the mountain. So what are they looking for here? So it says find BC, the distance from B to the summit. And again, the summit is the top of our mountain. So they are looking for from B to the top. So they are looking for this length right here. So from B to C. So how are we going to figure this out? Why don't you think about that for a minute? So do we have enough information to use the law of sines? So we are going to do the sine of 18 degrees and we want this opposite side of x. And what else do we have? We have this side, but we do not have its opposite angle. So if we knew this angle here, we could set up our proportion for this triangle. How are we going to get this angle when we know only the 18 degrees and we don't know this angle? Well, if you think about supplementary angles, we know from here all the way to here is going to be 180 degrees, and we already know this piece is 31 degrees. So if we want to get this piece right here, all we're going to have to do is take 180 degrees and subtract 31 degrees. So that would leave this measure to be 149 degrees. Well, that works out because now we know these two angle measures, so we can figure out what is left for this angle measure. So we're going to take 180 degrees, we're going to subtract out the 149, and we're also going to subtract out the 18 degrees. And when we do that, we're going to come up with this little angle measure left here is only 13 degrees left. So now we have enough information to do the law of sines. So we have this angle measure and its opposite side of 3,950. So we'll set up that ratio. So sine of 13 degrees divided by 3,950 is equal to the ratio of sine of 18 degrees over x. So now we can use law of sines. We can cross multiply. And to finish solving for x, we're going to want to divide by sine of 13 degrees. Again, you're going to want to make sure your calculator is in degree mode. If your calculator gives you a parenthesis, you're going to definitely want to close that parenthesis off. And the same thing for this one right here. So you're going to just type this all in your calculator, and we're going to come up with this length x is approximately 5,426.1 feet. And again, it's feet because our triangle is measured in feet. This is a multi-step sine problem. We definitely had more work to do in this one than the other one. We had to use the fact that we knew the 31 degrees to come up with this angle being 149 degrees by supplementary angles. And then once we had that, we had enough information to use our law of sines and find the missing length. So this is the length of, they actually asked for the length of BC. So technically I should be writing my answer as BC is approximately equal to 5,426.1 feet. Okay, well that is the end of the lesson on law of sines. All right, you guys, have a great day. Bye.